right, this is the beginning of our unit on chemical nomenclature. So we've done a lot of chemistry already in this trimester, and we've done a lot with drawing Lewis electron dot diagrams. We've drawn the shapes of those molecules. We've determined whether they're polar or they're non-polar. And so the next thing that we need to do is it's one of the things that's really important in chemistry is that when somebody gives you a chemical formula, can you tell them the name of that compound? Or if somebody gives you the name of a compound, can you write the chemical formula of that? And that's what this whole unit is about, is the ability to take a chemical name such as carbon dioxide, and do you know that that's CO2? Or if we take another compound like sodium chloride, can you determine that the formula of that is NaCl? So again, just like in all science, they come up with fancy words to describe things, but this word nomenclature, all that this word nomenclature represents is just represents name, okay? So we're talking about chemical nomenclature is the process of using a formula to determine the name, and then the backwards determine the formula, using a chemical formula to determine the name, and then to use the name to determine the chemical formula. Okay, so what's really important when we're doing chemical nomenclature, the first thing that we have to know is what type of compound is it, okay? And again, we've already talked about that. We talked about the three types of compounds that we've discussed are ionic compounds, covalent, and metallic. Now, first of all, the first thing we can do right away is forget about metallic, because metallic bonding is really, really easy. It's just the name of the element, okay? So if it's Cu, then it's copper. Or if it's iron, then of course the chemical formula or the chemical symbol for iron is Fe. There's nothing really tricky about metallic bonds at all. Okay, what we're gonna have to do some work on is we're gonna have to work on ionic, and then we're gonna have to work on covalent. Okay, so remember that an ionic bond or an ionic compound is typically made up of a metal plus one or more non-metals. Okay? Whereas if it's covalent compounds are made up of all non-metals. So the first thing that you're going to have to do, whether I give you, again, a chemical formula or whether I give you a name, the first thing that you're going to have to do is you're going to have to identify it. Is this an ionic compound or is it a covalent compound? Because even within covalent compounds, there's another tricky part, not tricky, but there's another part right here that talks about a special type of a covalent compound, which are called acids. Okay? Now, you can see there's a list of 5 different things there. Don't worry about those 5 things yet. We'll get to those here in a little bit. Okay? And like the next sentence says, none of these 5 are particularly difficult. The problem is there's 5 different things that we have to know and be familiar with, and it's really easy to mix those up in our heads, and that's why we're going to practice this a whole bunch, okay? So, but the very first thing that you're going to want to do is you're going to identify it. Is it an ionic compound? Is it a covalent compound? Or is it an acid? Okay, and again, whether I give you the formula or the name, you can figure those 2 things out. Okay, and we'll talk about that here in just a minute, about how to do that, especially with acids. So remember that, again, we've already talked about ionic compounds, we've talked about covalent compounds, and now we're going to talk a little bit about acids. Okay, and remember, again, here's some of the stuff that I wrote up here. An ionic compound is between a metal and one or more nonmetals. Okay, so an ionic bond or an ionic compound occurs between a metal and one or more nonmetals. Okay, and what's funny is when I wrote these notes, I forgot a word in here. Okay, however, there should be the word not. Okay, that is not exactly correct. I need to fix that in the notes. So we say, hey, an ionic compound is between a metal and one or more nonmetals, but that's not 100% true. When we were talking about it earlier, it was helpful. It's an easy way to do it, but really, an ionic compound has ions in it. And an ionic compound is always made up of ions, And specifically, to be an ionic compound, there has to be a positively charged ion, which is called a cation, and a negatively charged ion, which we call an anion. Now, normally, the metals are positively charged. The nonmetals are negatively charged. So again, it's pretty easy to say that ionic compounds are made up of metals and nonmetals. However, there are some positive ions that aren't made up of metals. One of them is what is called ammonium. Okay? For example, this compound right here, NH4OH, is made up of a positive charge, NH4 plus, and a negative charge, this is called hydroxide, which is OH minus. But notice that it does not have any metals in it at all. Okay, those are all nonmetals. And so that's why a better definition of an ionic compound is a compound that's composed of something with a positive charge and something with a negative charge. And again, usually that's a metal with a nonmetal. But sometimes, like in this case of ammonium, that is not the case. Okay, and ammonium is very, very common. Anytime you see NH4, we're going to talk about this later on, but that is a very common, ammonium nitrate is a very common fertilizer that you see in the real world. So that's a pretty common example of an ionic compound that's not made up of a metal and one or more nonmetals. Okay? Now, in terms of, so again, the best definition of an ionic compound, it's a compound made up of ions. It's a compound made up of positive ions and negative ions. Okay? In terms of covalent compounds, remember sometimes we call them molecular compounds, or we just call them molecules. Okay, there's nothing extra that we need to add about, well, we usually call it this, but it's not always that. Okay, with molecular compounds, it's just always nonmetals. Okay, again, just be careful though, because again, sometimes you do have these all nonmetal compounds that are ionic. And really the only one you need to be familiar with is ammonium. I'm sure there are others, but ammonium is really the one that you need to be familiar with. Okay. Because what if you have NH3 and you're like, well, he told us that NH4 could be an ionic compound. What about NH3? Nope, NH3, nonmetals, okay? That is definitely a covalent compound. Okay, so molecular compounds are made up of all metals, always, nothing new to add there. Okay, the only thing that we have to consider is this, what's this whole acid thing you keep talking about? Okay, and acids, they are all made of nonmetals generally. And there's a real easy way to identify an acid. For example, a very common acid that you might have heard of is an acid that's called sulfuric acid. Okay, gosh, Mr. Johnson, how am I supposed to know that's an acid? Because it says the word acid in the name. All acids say acid in the name. Okay, that makes the names really, really easy. Okay, well, what if I don't have the name? What if I only have the chemical formula? Okay, so an easy way to identify an acid over a regular covalent compound is the presence of one or more hydrogen atoms at the beginning of the formula, unless it's water. Okay, H2O is water. It is not an acid. Okay, other than water, if something starts with a hydrogen, we're going to presume that it is an acid. Okay, so for example, HBr is an acid. HC2H3O2. All the stuff that comes after the H, who cares? If it starts with an H, and again, it's not water, then we know that it is going to be an acid. Okay, so some other common acids, HNO3. It's called nitric acid. We'll talk about the naming of it later. I mentioned sulfuric acid. The formula for sulfuric acid is H2SO4. Again, what's that thing you see in common between all those acids? They all start with hydrogens. Okay, so just to review here, an ionic compound, the best way to describe it is a positively charged ion with a negatively charged ion. Okay, an easier way is metal with one or more nonmetals. Okay, a covalent compound or a molecular compound is made up of all nonmetals. And again, NH3 was an example of that. CO2, H2O, those are all just a few different examples of covalent compounds. And again, acids are they will either end the name with the word acid, or the formula will start with a hydrogen, which of course, unless it is water. Okay, water is actually really, really special. Water can actually act like an acid sometimes, but in general, we do not, when we talk about water, we do not consider water to be an acid, or what we would call an acidic species. Okay, so everything after this is all going to depend on, can you identify these particles as ionic compounds, covalent compounds, or acids? Because that's your very first distinction that you have to make, is what type of compound am I dealing with? Because if it's different, if you name it like an ionic compound, but it's really covalent, you're going to do it wrong. Or if you name it like an acid and it's not an acid, you're going to do it wrong. So the very first thing, this first assignment that we're going to do, is all based on, can you identify an acid? Can you identify an ionic compound? Can you identify a covalent compound?